In question 1 here it says, solve each inequality below. Also draw the solution on a number line for questions A to E. Now, these questions all deal with what we call sandwiched inequalities. So sandwiched. And in a sandwiched inequality, you can see we have two inequalities. And the idea is to isolate x in the middle. So let's look at A. Just like with linear equations, we always first get rid of what we're adding or subtracting. In this case, we are adding 3 to x, and we want to get rid of this 3 here. So we subtract through by 3. So minus 1 minus 3, then x plus 3 minus 3, and 4 minus 3. Now we can see that these 3's will cancel, and we've managed to isolate x in the middle. Negative 1 minus 3 is negative 4. 4 minus 3 is 1. Now we can draw this on a number line. It says x is greater than or equal to negative 4. So we use a dot to show that we are including negative 4. Then it also says x is strictly less than 1. So we use a circle to show that we are excluding 1. And then we connect these two. So basically all the numbers between negative 4 and 1, including negative 4, but excluding 1, will satisfy this inequality. We want to isolate the p, and we are subtracting 2 from p, so we can add 2 throughout. So 5 plus 2, so we add 2 to 5 here. We also add it to the p minus 2 and to the 8. So that's 7 less than, and here the 2's will cancel. So negative 2 cancels with positive 2. We're left only with p. So p is greater than 7, but less than or equal to 10. Now we can draw the number line. P is strictly greater than 7, so we use a circle here to show that we are excluding 7. P is less than or equal to 10, so we use a dot to show that we are including 10. And then we connect these two with a line. We want to isolate the x here, and since we are multiplying by 6, we divide by 6 through. So we divide everything by 6. The 6's here will cancel, and we're left only with x, and we can simplify this fraction. It's negative 1 over 2, as well as this one, which will be 2/3. Now we can draw a number line. X is strictly greater than negative 1/2, so we use a circle to show that we are excluding negative 1/2. X is also strictly less than 2/3, so we use another circle here to show that we are excluding 2/3. And then we connect these two. Once again, we want to isolate the t here, so we want to get rid of the half. Now, just to note that a half t is actually the same as t over 2. So essentially we are dividing by 2 here, and in order to get rid of the half, we multiply through by 2. But we must multiply everything by 2, so negative 4 times 2 is negative 8. Then we have a half t times 2. These 2's will cancel, and negative 1 times 2 is negative 2. So we end up with t greater than or equal to negative 8, but smaller than or equal to negative 2. Let's draw the number line. t is greater than or equal to negative 8. So we must use a dot here to show that we are including negative 8 as well as negative 2. And we connect these dots. Once again, we want to isolate the y here. And we always first get rid of what we're adding or subtracting. In this case, we are subtracting 3. So that means to get rid of this negative 3 here, we can add 3 throughout. Then negative 3 will cancel with this positive 3, and we're left only with 2y. So negative 1 plus 3 is 2, and 5 plus 3 is 8. Now we want to get rid of the 2 here, and since we are multiplying y by 2, we can divide through by 2. So 2 divided by 2 is 1. When we divide 2y by 2, the 2's will cancel, and we're left only with y. And then 8 divided by 2 is 4. Let's put this on a number line. We have y greater than or equal to 1, so we use a dot to show that we are including 1. Y is strictly less than 4, so we use a circle. So we want to isolate x here, and we always first get rid of what we're adding or subtracting. We're adding 1 here, so to get rid of this 1, we can subtract 1 through. So negative 3 minus 1, 4x plus 1 minus 1, and 5 minus 1. The 1's will cancel here, and we're left only with 4x. Negative 3 minus 1 is negative 4. 5 minus 1 is 4. Now we want to get rid of the 4 next to the x here. And since we are multiplying by 4, we can divide through by it. So negative 4 divided by 4 is negative 1. 4x divided by 4. The 4's will cancel, and we're left only with the x. And 4 divided by 4 is 1. We want to isolate the t here, and once again, we can first get rid of what we're adding or subtracting. Since we are adding 1 here, we can subtract 1 through. So negative 3 minus 1, a half t plus 1, minus 1, and then negative 1 minus 1. So this will be negative 4. Here the 1's will cancel. And negative 1 minus 1 is negative 2. Now we want to get rid of the half here. And a half t means t divided by 2. So essentially we are dividing by 2 here. So to get rid of this half, we multiply through by 2. So negative 4 times 2. Then a half t times 2, the 2's will cancel. And negative 2 times 2 is negative 4. Let's look at question 2. In question 2a here, we have to solve this inequality. We can get rid of this 3 here by subtracting 3 through. So negative 3 minus 3 is negative 6. 2x plus 3 minus 3 is just 2x. And 9 minus 3 is 6. Now we want to get rid of the 2 here, so we can divide through by 2. Negative 6 divided by 2 is negative 3. When we divide 2x by 2, the 2's will cancel, and we're left only with x. And then 6 divided by 2 is 3. So x is greater than or equal to negative 3. But strictly less than 3. In B, we have to write down all the integer values of x that satisfy the inequality. So we need to write down all the integers greater than or equal to -3, but strictly less than 3. And we can write this in set notation. So x is an element of the set. The first integer will be -3, then -2, then -1, 0, 1, and 2. Of course, we must exclude +3. Let's look at number 3. It says p is a prime number where p is greater than 60 but less than 80. So p lies somewhere between 60 and 80. P is 2 less than a square number. Find the value of p. Let's start by looking at some square numbers. We know 49 is a square number because it's 7 squared. The next square number after 49 will be 64 because this is 8 squared. Then we have 81 because it's equal to 9 squared. Now, p is a prime number between 60 and 80. And p is 2 less than a square number. So p will equal 81 minus 2. In other words, 79. Since 79 lies between 60 and 80, 79 is also a prime number. It's divisible only by 1 and itself. And it's 2 less than a square number.